Good evening, everybody. I'm working on the Proving Lines Parallel worksheet here. And, well, let's get going. So, remember, what we're doing here is we're not saying that the lines are parallel, therefore, specific angle pairs have relationships. Okay, so that's what we just did. We just worked on if the lines are parallel, then corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, and same side interior angles are supplementary. So now what we're going to do is we're going to flip that around. So notice how the question is phrased. Find the measure of the indicated angle that makes lines U and V parallel. Now, I'm going to be honest with you. The math here is going to be exactly the same whichever way we do it. I'm just trying to get you guys to understand that fundamentally we're finding something different. We're saying that that angle could be anything. So if we look at number one, that angle could be anything. But only when it's one thing are U and V parallel. So what is that one thing? Well, when we're looking at this, we want to keep in mind that we have four different angle pairs that we're looking at. Corresponding and same side interior. Both of those are going to be on the same side of the transversal. Okay? And then if they're on opposite sides of the transversal, we get alternate either interior or exterior. So, that's the transversal right there. The one that cuts across the two lines at distinct points. And we notice here that they are on opposite sides. So it's either got to be alternate interior or exterior. We look at that and we go, hey, they're in between the two lines, so therefore they're interior. So what we're going to do is we're going to look at the converse of the corresponding angle postulate. Excuse me. And we're going to get, if the two lines are congruent, then if the two angles are congruent, then the two lines are parallel. So that's got to be 134. Easy peasy. So that's basically how 1, 2, 3, and 4 are. You guys should be able to do them. So let's look at... Oh, okay. So what I just did there, that's actually a 46, not a 460. So if I were to instead look at if that question mark had been right there, then those two angles right there, they're same side interior. We know they're supplementary, so they'd have to add up to 180 degrees, so that would be 46 degrees. Moving on. So let's look at number 5. Now number 5 has 5 different lines on it. It's got 3 lines that look like they could be parallel and then 2 separate transversals. But notice a lot of that is just extra information, so we can get rid of that because all we're really looking for is what makes U and V parallel. And so what value of X is going to make U and V parallel? So those are our 2 lines, U and V. The transversal that creates the angles we're talking about is that right there. Everything else is irrelevant. So, we know that those 2 are same side interior. We're going to look at the alternate, or not the alternate, the converse of the same side interior postulate. And that says that if 2 lines in a transversal create same side interior angles that are supplementary, then the 2 lines are parallel. So we want to find out for what value of X those lines are going to be supplementary. Remember, supplementary means that the sum of the 2 angles equals 180. So that gives us X plus 186 equals 180. And we're going to subtract 186, so we get X equals negative 6. So that is the value of X. So X can be anything. But when it's 6, when X equals 6, U and V are parallel. Same idea over on number 6. All we want to do is care about the 2 lines U and V and the transversal. Don't care about those lines at all. So So here we have same or alternate interior angles. So we're going to say, what is the relationship between alternate interior angles? Well, over on the left side we said if they're supplementary, then they're parallel. Here we're going to say if they're congruent, they're parallel. Because the converse of the alternate interior angles theorem says that if two lines and a transversal create alternate interior angles which are congruent, then the lines are parallel. So congruent means that the measures are equal to each other. We're going to set up 1 plus 9x equals 46. Subtract 1 from both sides, divide by 9, and we get x equals 5. So again, x can equal anything, but when it equals 5, those two lines are parallel. Okay, so let's look at number 9 really quickly. So 9, here's the thing. And the reason I'm doing 9 is because it's a little offset. So you've only got 4 lines here. And again, that bottom one doesn't matter. What we are looking at here is we're looking at Cat wanted to say hi. So what we're looking here is corresponding angles, and let me show you why. Even though we're not normally used to this setup, that 50-degree angle and that 9x minus 4 are both on the top left. So we know that the converse of the corresponding angle theorem says that if corresponding angles are congruent, then the two lines are parallel. So I'm going to set it up as 9x minus 4 equals 50. Add 4 to both sides, 9x equals 54. Divide by 9 and we get, x equals 6. Okay, so when x equals 6, u and v are parallel. So now I want to show you kind of how to do these last 4. I'm only going to do one of them, leave the rest for you. So we're asked to find the measure of the angles indicated in bold, which would make the lines parallel. Now I know that technically a lot of these are already marked parallel. I want you to ignore those right now and pretend they're not. So here we have those two angles, x plus 98 and 92 plus x. Those are going to be same side interior angles. And again, looking over those little quick checks you guys did today, the biggest issue you guys had was in making sure that you correctly identify the angle pairs and understanding that those angle pairs have specific relationships. So same side interior or supplementary when two lines are parallel, alternate interior angles, alternate exterior angles, and corresponding angles are all congruent when the two lines are parallel. So here we're dealing with supplementary angles. So we can say if the two angles are supplementary, then the two lines are parallel. So we set it up as x plus 98 plus x plus 92. I use the commutative property of addition to flip those around. Equals 180. That gives me 2x plus 190 equals 180. Subtract 190 from both sides, and I get 2x equals negative 10. Divide both sides by 2. And I get x equals negative 5. Now, that's not enough. Now I need to go and I actually need to take this 5 because I need to find the measure of the angle. Take this 5 and I'm going to plug it back in. So that gives me a negative 5 right there. Negative 5 plus 98. So this angle right here is 94 degrees. You can double check that. 92 minus 5 is 80. So it's not 94, it's 93. And 92 minus 5 is 87 degrees. 93 plus 87 is 180, so we're good to go. Hope this makes sense. A lot of it is just kind of an identify them, and so we should be able to move forward. Have a wonderful evening, everybody. I'll see you guys tomorrow.